Hi guys, welcome to Make to Explore YouTube channel. First of all, we thank all our subscribers and viewers for all the support and encouragement you have given to us.
Now let's blink onboard LED of Raspberry Pi Pico. Let's write MicroPython program for it. Open Thonny IDE. We've seen earlier in this video about how to download and install the Thonny IDE. Here is the interface of Thonny IDE, which shows its toolbar here. Then here is the editor or scripting area where we are going to write a program. This is the shell or console. You can see here in shell that we've connected to Raspberry Pi Pico with RP2040 MCU and it is running MicroPython on it. This is its REPL prompt, read, evaluate, print, loop. You can also verify this in the bottom right of this IDE, where it is showing that we have connected to Raspberry Pi Pico. So this was about the interface of Thonny IDE. Now, let's write program to blink the onboard LED of Raspberry Pi Pico. So you can see here in Pinout Diagram that our Pi Pico have onboard LED connected to GPIO pin 25. Now let's write the program. Here is the code. Don't worry, we'll explain each line of code one by one. First, we have imported the machine library. This short line of code is key to working with MicroPython on your Pico. It loads, or imports, a collection of MicroPython code known as a library, in this case, the machine library. The machine library contains all the instructions MicroPython needs to communicate with the Pico and other MicroPython compatible devices, extending the language for physical computing. Without this line, you won't be able to control any of your Pico's GPIO pins, and you won't be able to make the onboard LED light up. Then next we've imported timing library, utime. This library includes all the functions related to the timings, like delays, sleep, etc. Then next we have defined an object for onboard LED, which offers friendly name to your Pi Pico's onboard LED. You can give any name, but to identify it specifically we gave it as LED_onboard, which is easy to understand and readable. In second part, we call the pin function from machine library in which we set up GPIO 25 pin as of output. To blink the LED connected to pin 25 we need to set it as output rather than input. Previous line of code won't light up the LED, there we've just set the direction of GPIO pin. Now we need to tell Pico that what value to put on GPIO to turn the LED on and off. Here, in this line, LED_onboard dot value, we pass the value 1 to turn on the LED and value 0 to turn off the LED. Now if you run this program at this point without delays we will not see blink effect because Pico runs very fast, far more quickly than human eye can see the LED turned on and off. So, we need to insert delays here to fix that. Therefore we've included here function utime.sleep which is from timing library. Here we need to create two separate delays, one for LED turn on time and one for turn off time. These lines of codes will surely create the blink effect, but only for once. If you run this program without this while loop, we'll see LED blinking effect only once. To see the continuous blinking effect, we have to include all the above code into a forever loop, that is while loop, with always true condition. Here, you can see, after this colon, if you press enter here, Thonny IDE will add 4 spaces automatically. This shows that we're entering into a loop. It is a standard syntax of MicroPython to add these 4 spaces at starting of each line of code for the one which you want to execute them into the loop. Therefore these all 4 lines are in this while loop. So this is complete LED blinking code. Let us save it first before running it. When you click a save button here, this will pop up a window which will ask us to save it into local machine or to your Pico. So, let's save it on Pico. Give name as blink and give extension as .py because it is a MicroPython program. Finally, you can run this program. For that, go to above toolbar and click on Run button. Voila, there it is, LED is blinking. You can check that out in this insight window. We'll see more projects using Raspberry Pi Pico in coming videos. Thank you.